Hello students, this is some important things about moving coil galvanometer, and this is the diagram of the moving coil galvanometer. And now in this video we will discuss about the working of moving coil galvanometer, and basically start from the moving coil. What is moving coil? This is the moving coil wrapped around a soft iron core. Why on soft iron core? This is the first question. Because soft iron core is easily magnetized and easily demagnetized. So it is wrapped on soft iron core. And this is the coil. These are the spirals attached to the coil. When the coil start fluctuate, then the spiral develop a restoring force on it. In 11th class you have studied about restoring force. This tends to move a body towards equilibrium. So this is the spiral to make it in equilibrium in mid of this pointer in the middle of the scale. Now when current is passed through the galvanometer, then the current in the coil experience a torque due to applied magnetic field of this north pole to south pole, and the maximum torque on the coil may be at an angle 90 degree. So the torque will be mb sine 90. We can put here sine 90 for our maximum value, and it's not problem. Okay, this is the maximum value of the torque, sine 90, and well known, the magnetic dipole moment of the coil NIA is I is the current in the coil, A is the area of the coil, and N is the number of turns of the coil. Okay, and this torque is directly proportional to the angular deflection, and this K is the proportionality constant and also called torsional constant. Basically, torsional constant is the effect of the constant that is involving various things such as moment of inertia, is a major factor in this case when the body rotates about any axis. So this is the, we can say also that inertia factor. Okay, this is the inertia factor or torsional constant. Now, that why the magnetic field in the shape of this north and south is of this type that it can concentrate the magnetic field on the center of the coil, and the maximum value of the magnetic field pass through the coil. So the magnetic field should be constant and radial along the radius of the coil, central coil. Okay, so it can develop the maximum torque, and the value of B should be maximum through the coil. In this case, we can find this. This is the working of the moving coil galvanometer. Is simple, and this is a permanent. We can say permanent magnet here. This is made of stainless steel for long time, long age. And why? Both are different terms of the moving coil galvanometer are defined as current sensitivity and voltage sensitivity. So how we can write current sensitivity and voltage sensitivity? So first we write current sensitivity Okay, this is the angular deflection upon current. Okay, this is the current sensitivity, and similarly we can write voltage sensitivity. It is also similar, angular deflection per unit voltage, two definition. These definitions are beneficial for the conversion of the galvanometer into ammeter and voltmeter. Basically, galvanometer is not a measuring device. It is only to check the presence of current in the wire. Okay, it does not measure the current. Okay, so this is the moving coil galvanometer, and why the magnetic field is radial. So it is to develop maximum torque on the coil. Why the soft iron core having low retentivity, and something that it is easily magnetized and demagnetized. This is why this is a permanent magnet, because we have long life for this, made of stainless steel, the permanent magnet. And these are the simple definition based on the moving coil galvanometer. I hope it's very simple, and having a marks of 2 marks in the board for this. Okay, only 2 marks of the weightage of this, and I hope it's clear to you. And in next we will discuss our further points. Thank you. Thanks for watching this one.